Okay guys, here's some homework help on 8.5. Once again, you're going to want to have your unit circle as you go through these, but I thought I would just do a couple of examples. There's a lot of problems on here, but literally these are going to take you just a second using your unit circle. As an example, I'll just do this one here, tangent of 45. Remember, if you take back your unit circle, take that out. Remember, I told you that tangent is y divided by x. So if I go to 45 degrees, and I look at my coordinate, square root of 2 over 2, square root of 2 over 2, and I take y divided by x, I'm going to get the square root of 2 over 2 divided by the square root of 2 over 2. Hey, that's just 1, isn't it? When you have the same thing divided by the same thing in both the numerator and denominator, that's just simply 1. How easy is that? There was one I thought that was a little bit tricky on here, and that one was number 18 or 16, excuse me, only because I said that all of these are going to be on the unit circle. That one is not on the unit circle. If I went here and said, okay, where's 13 pi over 4? But remember, we learned back in, I believe it was 8.3, we learned something called coterminal angles. Coterminal angles are angles that fall in the exact same place. So 13 pi over 4 does fall on the unit circle. I'm going to just forget about the negative part for right now. And what I'm going to do is I'm going to change that to a degree. Remember, I showed you how to do that in 8.3. If I took 13 pi over 4 and I changed that to a degree, just so I could get a better idea of what that's going to be. The pi's are going to cancel. 4 divides into 180 45 times. And what is 45 times 13? Oops, I didn't mean to cancel off the 13. I meant to cancel off the pi. Sorry. I still have a 13 there. So 13 times 45 is 585 degrees. Now remember coterminal angles, right? So I want to know how many 360s goes into 585. So if I take 360 and then I subtract 585 minus 360, minus 360, I'm going to get 225. So here's how it's going to work. We know that we're going to go one full rotation plus another 225 degrees. So if I look at my unit circle, here's 225 degrees. Now, the only thing is that it's negative. So if I were coming from here, right? If I were coming from 0 in a positive direction, coterminal angle would be at 225. However, what I'm going to do here is I'm going to go, how many degrees was that? 225. So you're actually going to have to go clockwise 225. So clockwise 225 is going to land you right here at 135 degrees. And so what are we looking for? We are looking for the sine of that, which is going to be the sine is our y coordinate. So that's going to give us square root of 2 over 2. And that would be our, so that one, yes, is tricky. That one was tricky. This one also kind of the same thing. Change it into a degree and then figure out what the coterminal angle would be. So yeah, it's the same thing, except you'd be going in the positive direction. So if this weren't a negative, it would have just been whatever 225 is. And it would have been, the y coordinate would have been a negative, right? But it wasn't. It was positive because we had to go in the negative direction. Okay. All right. So from there, what we're going to do is we're going to take a look at, there was 2 reviews. So I'll get to the reviews in a second, but let's take a look at this one here. This one we are looking at the working backwards here. Remember arc sine, arc cosine. So what you're doing is you're finding that coordinate and then just looking at the domain. So I believe I did a couple of these already, but as an example, cosine inverse is square root of 3 over 2. So what you would do is you would go to the x coordinates of positive square root of 3 over 2. The x coordinates of positive square root of 3 over 2 would be here and here, right? But remember the domain of cosine, if I take that slide back out, remember the domain of cosine says you have to stay up here in quadrants 1 and 2. And so if I'm looking at this, the square root of 3 over 2, it would have to be this guy right here, because this one down here doesn't fall in the right domain. So the answer will be either 30 degrees or pi over 6. And it doesn't say if we have to write it in radians or degrees, so I'll just write both. And so that's what you're doing on this whole page. Down here, I did want to take a look at this one because we didn't do anything like this in the notes, but remember, cotangent is the reciprocal of tangent. And remember, tangent was y over x. So if I assume that this is 1 over 0, which I would have to assume that, the reciprocal of 1 over 0 is going to be 1 over 0, right? Because we don't know what cotangent is, but we do know we would have to find the tan inverse and then flip it, right? Well, 0 in the denominator is undefined. And so this right here would have to be undefined, right? Because it would be 1 over 0. And the other thing too, this one it says cosine inverse of 2. Well, if you look at the unit circle, there's no x coordinates that are a 2. They're not, there's nothing on there. This is called the unit circle. That means your radius is 1. So this one right here would also be undefined. Those are the only 2 that are undefined on this page. So just the rest of them you should be able to get to. And then the last page, actually I did a couple of these already for you. In fact, I think number 16 is on in the lesson that I just did. And I believe there was another one, maybe number 21 as well, or maybe it was 20. I'm not sure. I think it was 20 that we did. So that's how you do those. Remember, you work inside, get the answer to the inside, then so it's kind of like you're doing the first part of the worksheet, and then you're doing the second part. So you're going to figure out what the inside is and then work your way out. Okay. Let's look at the reviews. There's actually 2 reviews because I don't know why this was broken up into 2 lessons. I think just to make it really short on a quiz day. But let's take a look at both reviews, just, a good review. This one is from Unit 7. We wanted to remember Unit 7 had the logs and the exponentials. So we wanted to graph this. So remember, put this in exponential form. We did this right before we ended. You were actually going to have a test on this, right? Had we not gone into quarantine. But remember, the easiest thing I feel to do is to plug numbers in for y. So remember, the numbers we used to do were -1, 0, and 1. So 3 to the -1 is 1/3. 3 to the 0, anything to the 0 is 1. 3 to the first is 3. And if I go to my graph, 1/3 -1 is going to be maybe about there. 1, 0 right here. 3, 1 would be about here. And remember, a logarithmic function had a vertical asymptote, and this is just a parent function, right? And so it follows the asymptote up, and there would be your graph. Okay. So remember the couple situations here. Can I make the bases match? I don't know if that was supposed to be a 49, but it's obviously not. So remember, how do we remove the base of an exponential function? Remember, was to take the log base of whatever your base is. So I would have to take the log base 7 of 7 to the x plus 3 equals the log base 7 of 79. So remember, that cancels, and you're just left with x plus 3 equals log base 7 of 79, and then you would subtract 3 from that. So it would be log base 7 of 79 minus 3, and then you could calculate that. Do you remember how to calculate that? You would have to use change of base. Log of 79 divided by log of 7, and then take that answer and subtract 3. Okay? And this one actually pertains to what we're doing now. It says the dimensions of the right triangle are shown below in feet. What is the sine of theta? And this is a practice ACT. So remember, katoa is the ratio. Sine is opposite divided by hypotenuse. So if I'm here, opposite is A, hypotenuse is C. So it would be A over C. The answer would be G. Okay. The other review is from Unit 5. which was at the very beginning of the year or the semester. This was back in January, but we wanted to solve for x. So remember, you had to get the LCD. So the LCD in this case is going to be 2x. And so you're going to multiply by 2x, 2x, 2x. The x's cancel. We have 8. The 2's cancel. We have 5x. The x's cancels. We have 22. And then you're going to solve that. Pretty nice. So we're going to subtract 8. What is that? 14, right? And then you're going to divide by 5. And we get x equals 14 over 5. Okay. This one is a division. Remember, you have to do the reciprocal of the second one, but remember the first thing is factor anything you can factor. I see a GCF of 2x squared here. So that's gonna leave me with x minus 6. This is factorable. 2 factors of negative 12 that add to be negative 4 would be a negative 6 and a positive 2. Oops, it's a minus 6. X minus positive 2. And then remember, you're going to times by the reciprocal of this. So I'm going to factor this, but it's going to go in the denominator. I see 8 and x squared. And then that's going to leave me with x plus 3. And then down here, 2 factors of 18 that add to be 9 would be 6 and 3. And once you have that, then the fun part, remember, was... Okay, so hopefully it didn't stop recording. I was just popped off there for a second, but hopefully you got this. Okay, so there's your answer there. And then the last one, it says P is, it says 0.12 x plus 3,000. The slope of line M is 0.1, and they're telling us that these are both just regular lines. It says line N is 0.1 greater than the slope of line P. What is the slope of line M? Well, the slope of line P is 0.12 or 0.12. Right? You don't need the x for slope. Slope is a number. And we're going to add, it says greater than, so we're going to add 0.1 to that. Well, that's going to be 0.22. Well, that's pretty easy. All right, guys. All right, so there's some homework help on 8.5. Hope that helps. If not, make sure to attend the meeting I'm going to hold to help you in person. Bye.